Hello, this is part two of the TSI Math Exam 3. So we'll finish off on this video. So we stopped off on question 38, and we got to convert 3 feet cubed to liters. So they give us some conversion. 1 inches is equal to 2.5 centimeters, 1 centimeter cube equals to 1 milliliter, and 1,000 cubic centimeters, or you could think of it as 1,000 cm cube is 1 liter. So what we could do is just do it all at once using fractions or dimensional analysis. So what we got to do is start with what we have. So we start with 3 feet cubed. You could put an invisible one under the feet because it doesn't have a fraction. And then let's get rid of the feet cubed. So I'm going to put feet cubed here. And then I'm probably going to put inches, and I'm going to put inches cubed. So what is the relationship between just regular feet and inches? We know that 1 feet is 12 inches, right? We have a problem. We want it in feet cubed and inches cubed. So 1 feet cubed, or that's the same thing as 1 to the third, is still one. And then this would be 12 to the third, which gives you inches cubed, right? So what is 12 to the third? It is 1728. So one here and then 1728 on the top. And then what I'm going to do is get rid of the inches cube. So I'm going to put an inch cube here. And then I'll probably have to use what our conversion is. 1 inch is to 2.5 centimeters. So I'm going to put a centimeters and I'm going to make that cubed. But be careful, we have it in inches and centimeters, not inches cubed and centimeters cubed. So 1 inch equals to 2.54 centimeters. That's given. But we want it in cubes, so 1 inches cube. That's like the same thing as 1 to the third, which is still one. And then we got to raise this to the third. 2.54 to the third gives us centimeters cubed, right? So what's 2.54 to the third? It is, mm, it's kind of large. It is like, I'll just leave it as 2.5. 2.54 to the cubed. Okay. I'll just leave it as that because it's kind of it's a long decimal. Then I want it in our goal is to put our final answer has to be in liters, so I'm gonna have to put centimeters cube on the bottom, and then we could use milliliters because they tell us that 1 centimeter cube is 1 milliliters. So I could put one here and then 1 milliliter here. And then let's convert that milliliters to liters. So put milliliters on the bottom and liters on the top. So what is the relationship between liters and milliliters? Well, I think that 1 liter is 1,000 milliliters. Let me double check. That's, oh, we don't even have to do that. Look here, 1,000 centimeters cubed or 1,000 cm to the third power is equal to 1 liter. That's what the unit I should use. I don't have to do this extra conversion. I just could go straight to liters. Okay. So I'm going to put a centimeters cube on the bottom because I want to get rid of these centimeters cube. And it says, and then I'm going to put liters on the top. So they're saying that for 1 liter, there's 1,000 centimeters cubed. Okay. Then just multiply it out across. So 3 times 17 times 3 times 1728 times 2.5 cubed times by 1, and then go ahead and put that in the calculator. That's 84,950.53,978. And then on the bottom, it's 1 times 1 times 1 times 1, which is and then times it by 1,000, which is 84.95 liters. Okay. So I guess we didn't really need this extra conversion of 1 centimeters cubed to 1 milliliters because once we have this in centimeters cubed, I could have just used this conversion and that's it. 39 says a cyclist descends a hill, reaches a maximum speed, and then starts slowing down as the land becomes flat. What does the area under this graph represent? So the area under this graph, we have a time on the x axis, and then on the y, we have speed. So what is the relationship between time and speed? Um, I believe it would be, I think it's either the acceleration, because when you have acceleration, you need some kind of speed and time. We'll check. Yeah. So you have position. So you have change of position. So change of position over change of time, right? It's like a slope, right? Change of y over change of x. Our y is the speed, which is this position, and then oops, and then our x is time. So that would be oh no, never mind. What does the area yeah, never mind. I got that mixed up with another problem. It is actually going to be so we have speed. Yeah, it is definitely it's distance. The reason why it's distance because we have the speed, so it is still change. Yeah, it is still change of y over change of x. Change of y is speed, which is technically I'm sorry, no, it's actually I got they're saying what is the area? So what is the area? It's basically length times width, or in our case, it would be the x times the y. The x is the time, y is the speed, which is basically distance over time. And then what happens is the times disappear, so you're left with distance. Okay. So the area under the curve is basically length times width, or in our case, x times y, and our x unit is time, and our y unit is speed. And speed is distance over time, which is distance. Okay. Okay, here we go. Question 40. Given the set data points below, what best describes the relationship between the values of x and y? So we have this dot plot. They look like they're going to the negative direction. I think it's going to be, I think it's going to be, it's not constant because if it's constant, it's either going to be completely horizontal or vertical, which we don't. Is it directly proportional or inversely proportional? I don't think it's C. So I don't think it, you can forget about A and C. Um, I think it is directly proportional because what is the equation of directly proportional? It's basically y equals k times x. And that's what we have. We have a linear line because kx, y equals times x is the same thing as y equals mx, right? Um, yeah, I think it's B. Okay, so you need to know that directional proportional is the equation y equals kx, which is a linear line. Inversely is like a fraction, which is a rational function, which is not, this is not a rational, it's a linear. Okay, question 41. The following depicts the position of a cyclist at a various moments in time based on the points measured. What is the best way to qualitatively characterize a cyclist's speed? Is it A, changing times, B, D, accelerating, C, constant, or D, accelerating? So yeah, here we have this linear line. On the X, we have the time, and then on the Y, we have position. So yeah, I think it's going to be constant. It's not changing direction. It's not deaccelerating. It's not, is it accelerating? I don't think so. Yeah, the reason why is because it is constant because as speed is given, speed is change of position over change of time. Yeah, what is this one called? Yeah, the speed is constant. Yeah. Um, you may increase time and position, but you could think of the speed as a slope, right? The speed is like the slope. And in a slope of a linear line, it's always the same, so it is constant. Question 42. A restaurant manager is conducting a survey to gather feedback on the quality of service provided by the wait staff. Participants are asked to rate this service on a scale from 1 to 10, where 1 represents poor and 10 represents excellent. What type of variable in the service rating is in the survey? So is it A, ordinal, discrete, interval, or D, categorical? I think it would be interval because when we're doing scaling 1 to 10, let me double check. Yeah, not, I mean, ordinal, sorry. It is a ordinal. The reason why ordinal is because this is a service rating. So anything that's related to service rating is an ordinal variable. Ordinal variable represents categories with a natural order. So anything that has some kind of order, it is ordinal. Okay, so it's going to be A. Question 43. A fair six-sided die is rolled. What is the probability of rolling an even number? So here we have a probability problem, and then Probability is total outcome on the bottom, and on top it's your desire. So it says that we have a fair six-sided dice, and we're only rolling one dice, so the total outcome is six. What is the probability of rolling an even number? So you have a one, a two side, a three side, a four side, five side, and a six side. So which of these numbers are even? So two is even, four is even, six is even. So that you have a total of three chances. So it's three out of six, which can be divisible by three. So six divided by three is two, go to one half. 44. A teacher recorded scores over 15 students on a math quiz of 95, 85, 88, 92, um, etc. What is the mode? So the mode is the number that occurs most often, and I believe, yeah, the number that occurs the most often. I mean, you can have more than one mode, but they want one mode, so it's the number that's the most often. Um, it says the mode is going to be. I have it in my notes, so I don't want to. Okay, I'm just gonna look at it. Let's see. Let's look at 92. So how many times does 92 occurs? It's one, two, three, four, four. Okay, what about 85? Does that even occur often? Let's see. One, two, three, four, four. What about 88? 88 is one, two, three, four. What about 92? One, two, three, four, five. What about 75? Let's see, 75. One, two. So the number that occurs most often between these numbers is 92. That's it. Okay, 45. A factory produces light bulbs and the probability of a bulb being defective is 0.05. If a box contains 10 bulbs, what is the probability that at least one bulb is defective? So it's basically 1 minus 0.05, and then a box contains 10 bulbs, so we're going to raise it to the 10. So it's basically 0.95 raised to the 10th. Or you could put that exactly in the calculator. So minus 0.05. I get 0.598. So what is the probability at least one bulb is defective? Wait, 0.5, 0.6. I don't see 0.6. I think they just want one bulb, so it would be 0.95. I think it's C. A data set has a mean of 60 and a median 55. Which of the following statement is true? Is it A, the data set is right skewed? B, the data set is left skewed? C, the data set is symmetric? The date or D, the data set cannot be determined. So a data set has a mean of 60. So our average is 60 and a median of 55. Um, I would say I would say right skewed. Yes, right skewed because in a right skewed, the distribution of the mean is greater than the median. So in a right skewed, the mean is greater than the median. Is this true? What is our mean? Is 60? Is it greater than our median? Yes, 55. So this is how you know it's right skewed, because if the mean is greater than the median, that's how I know it's right skewed. Okay. 47, a restaurant owner decides to calculate how much revenue they gain from sodas each month. What type of variable would the amount of revenue gained from the sodas be? Is it continuous, categorical, discrete, or nominal? I think there's going to be, I think it's going to be continuous. The reason why the amount of revenue gained from selling sodas would be continuous variable because within the within the limits, the variable ranges any values as possible. Decimals are allowed. So anything with decimal is continuous. Uh, Last one. What is the median size in the following data set? Median is the number right in the middle. So maybe if we list out all the numbers. So one, the number one hits it once. The number two hits it twice right here. So write out two twice. Three is a total of three times. So write out three times. Four is twice. One, two. Five is once, and six is four times. One, two, three, four. Okay, so how do we find the median? We basically pick the number right in the middle. But let's first count how much numbers we have in total. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Because 13 is odd, all you got to do is pick the number right in the middle. So what is it? Is it number three or is it four? So let's look three. How many numbers to the left? There's one, two, three, four, five. But here after three, so it's one, two, three, four, five. No. Is it four? So how many numbers are left? Four. There's one, two, three, four, five. One, two, three, four, five, six. And then after four is one, two, three, four, five, six. Yes, the median is definitely four. Okay. So that is C. Now let's check our results because I really do I want to know if I made a mistake. have one problem I must have made a mistake on. Let us view. So we have a 97.92. So I'm going to see what the mistake I made. So everything else is correct. There's only one mistake we made. Hmm. Okay, we got that one right. 26. Which one did I get wrong? Right. Here we are. Uh, it's this question. So the correct answer is what? Oh man, I thought I picked directly proportional. I thought so that's what I said. Um, it's actually no, it's the correct answer is inversely proportional. So here we have this scatter plot. It's going to the left. I thought it was linear, but I guess I was wrong. Let's see. The values of y showing decreasing trends as x increases. Therefore, we suspect it's an inverse relationship between these two variables. So yeah, that's why it is inversely proportional. Let me double check. So the equation of inversely proportional is y equals k over x. Um, yeah, so the values of the y shows decreasing trends as x increases. So as x increases, y decreases, right? As x increases, y decreases, and as y, so wait, let me write this down. As x increases, the y decreases, and then as the y increases, the x decreases. So that is why it's inversely proportional. Okay, I think that's the only one I got wrong, so everything else is correct. Okay, perfect. I'm going to stop here.